Good morning, everyone. Welcome to another video. In this one, we are looking at our final version of factoring, and this is called decomp, and it's just adding to the pieces that we have. We can do GCF, we can do inspection, we can do difference of squares, and then the fourth and final method is decomp. And between today and tomorrow, we're going to look at a bunch of different scenarios and really finalize decomp. Decomp can be used for a variety of things. It's a really solid method. Takes a bit more time. It's a little bit takes a bit more space on your page, but it works, right? It's going to get you the right answer for a variety of things. So that's why we look at decomp, and that's why we use decomp. So with that said, let's jump in. Here we are, workbook page 355, and we are going to look at our last method of factoring. And this is kind of a big one. This is a method that we can use for a variety of polynomials. And it is a doozy. So what we are looking at today is trinomials, okay? But specifically when I have an a value that's not 1. So typically we've just had the x squared plus whatever plus whatever. Now it's like 2x squared or 3x squared or 4x squared or whatever. I actually have an a value. So I can't just do inspection, okay? I can't just quickly look for that magic combo. I have to do something different. And that method is called decomposition, and I'll get into more of that later. To start, let's kind of remind ourselves, right? Factoring is the opposite of multiplication. So certain things, right, like this product, these two factors would multiply out to a trinomial, and it's not just x and x. There's going to be something in the bracket, so I have to know it's not always just inspection. When I have an a value bigger than 1, I have to do something different. And these are maybe some ways to think about that. So if I multiply that out, I would get 6x squared, okay? And then I would get plus 8x plus 3x. So that's actually plus 11x. I'll do that one in my head. And plus 4. So what that's saying is, yeah, 6x squared plus 11x plus 4, that has factors. I could factor that to 2x plus 1 times 3x plus 4. That's the product that multiplies out to 6x squared plus 11x plus 4. So just because I don't have the a value of 1 doesn't mean it can't be factored. I'm just going to need a different method. Okay, same thing for the one below. I could multiply that out, 12x squared plus 9x minus 8x, so just plus x, and minus 6. So again, I'll do that one in my head. Normally I would show my work, but there's just no space. So what's that saying is if I ever had 12x squared plus x minus 6, I could factor it to 3x minus 2 times 4x plus 3. Okay. Well, I guess the issue is then, how could I factor these things? Inspection is not going to work, right? Because inspection just kind of has an x and an x, and then I jump to my magic combo. This first one had 2x and 3x, this one had 3x and 4x, so clearly I need a different method. Well, the first idea is to use algebra tiles. So I'll do one example with algebra tiles, and then I'll show you a way without, okay? The whole idea, the same exact thing that we did when it was kind of starting inspection is, okay, well, here I have 2x squareds, I have 7x's, and 6 is my constant. I know that factoring is just trying to write it as a multiplication statement. So if I were to represent it with area tiles, and I could push it into a rectangle, the length and the width would be my factors, because length times width gives me the area of a rectangle. That's a product of two factors. So how can I arrange these into a rectangle? And it's a lot harder to do when you don't have them. I'll jump to my camera. There I have it, my 2x squareds, my 7x's, and my 6. Well, I'm going to start by putting these two big x squareds together. Okay. Well, that's a rectangle right there. And then I'm going to try to build around it. Maybe I say, okay, I could fill that. Oh, and then if I just fill the corner, that's still a rectangle. Okay. And then maybe I try to continue that pattern. Maybe I throw another one here. Is this going to work? We'll see. Okay, I've kind of filled the rectangle, but then I have some missing pieces. Okay, so that's still a rectangle, and I've got a couple pieces to add. Oh yeah, I guess I could just add it in over here. If I tried to add it in over here, I have an incomplete rectangle, so I have to add it in on the top. Okay, and there we go. So it's really trial and error. It's just kind of pushing your pieces around, trying to form a rectangle. But now I have my two dimensions. I have x plus 2, and I have 2x plus 1, 2, 3. My two factors. So I'll go back and draw that, and then we'll talk about the factored version. Okay, so I had, let's see if I can remember now, an x squared, another x squared, and 1, 2, 3 x's. And then along the bottom, I think I had 2 rows of x's. There we go. And the rest was filled with sixes. With 6, all of the 1s. So there you go. I have my 2 x's, 2 x squareds, I have my 7 x's, and I have 6. That is a rectangle. The area of that rectangle could be written as the product between x plus 2 and 2x plus 3. There you go. So what we're saying is 2x squared plus 7x plus 6. The factored version of that is the area of that rectangle I just said. X plus 2 times 2x plus 3. Hey, I factored it. That is the factored form of that polynomial using the tiles method. Okay, so the whole idea is, yeah, I can push the tiles, and as long as it forms a rectangle, I can factor it out to the length and the width. Well, yeah, it's okay. It's good to think about the rectangles. It's good to think about that. But I need to be able to do it without tiles as well. And especially you guys at home don't have tiles, so that's why we're really going to use the other methods. So let's move on to the next page and jump into the next example. Okay, we're going to skip. There's another one asking to do with tiles. We're going to skip it. We're going to go to here, where we're going to review factoring by grouping. So a quick review of factoring by grouping. This is something we looked at maybe on the second day of factoring. And this was a method when I look at something, it's got 4 terms, I don't have any GCFs, so I have to group it into smaller sections. And factoring by grouping was to say, okay, take the first 2 terms and factor them, and then take the second 2 terms and factor them. So within this question, the first 2 terms, 6x squared plus 3x, I could factor out a 3x. And I'd be left with 2x plus 1 in the bracket. In the next little grouping, 8x plus 4, I could factor out a 4, a positive 4. So plus 4, and then I'd be left with a 2x plus 1. And the convenient thing you notice is, hey, in each of those terms, you actually have that common factor of 2x plus 1. So in this term, I have a 2x plus 1. In this term, I have a 2x plus 1. I can bring it out. I can factor out now the common factor that is actually a bracket. Okay, 2x plus 1. And what I get left with is, well, I cross out the 2x plus 1, I have 3x. And I cross out the 2x plus 1, I have plus 4. 3x plus 4. So there you go. I am factored. Okay, factor by grouping. 2, again, same thing. 12x squared plus 9x minus x minus 6. There's no common factor. Okay, so I'm going to factor by grouping. This one's a little bit trickier. Okay, first term, 12x squared plus 9x. They could both have a 3 and they could both have an x. So I bring out a 3x and I'd be left with 4x plus 3. And then in the next group, negative 8x minus 6, I always factor out the negative on that first term. So it's a negative 8x. I am going to factor out between 8 and 6 not only a 2, but a negative 2. So subtract 2, and I'd be left with 8x divided by negative 2. I get 4x. Negative 6 divided by negative 2, positive 3. And hey, it worked out perfectly. 4x plus 3. 4x plus 3, I have that common factor again. that I can factor out. The 4x plus 3 comes out front. I factored it out. That was the GCF. And then within the terms, I had a 3x and a minus 2. So that's factoring by grouping. Okay, that's factoring by grouping. Okay, well, we're going to do that within the method of decomp. So below, there's a lot of information on factoring by decomp, but I'm going to skim through it. Okay, in your workbook, you could read through it a little closer if you wanted. Wouldn't be a horrible idea to get a read through in your own words, but I'll just skim through. Okay, so basically what it comes down to is that first one we did, 6x squared plus 3x plus 8x plus 4, that's really 6x squared plus 11x plus 4. If you combine those terms in the middle, so this is the one we just did. This is really what I factored, but I would have had no idea how to factor that because I can't use inspection because it's got the a value of 1. So I decided we split up that 11x into 3x and 8x. And then I could factor by grouping. So that's interesting. There's some way that I can split up that middle, and then I'm able to factor by grouping. And what it goes down to is, well, why did it split into 3x and 8x? Why not 2 and 9 or 1 and 10 or 5 and 6? Why did it specifically choose 3x and 8x? And that's what we're going to dive into, and that's what we're going to decide. Okay, same thing for part 2, right? That was 12x squared plus 9x minus 8x. Well, if you combine your middle terms, 9x minus 8x is just plus x. So why did we decide to go with 9 and negative 8? Okay, why was that what we chose to split it into? Okay, well, the answer, and I think this is on the next page for you, okay, I think this is on the next page for you, is right here at the very bottom, the last thing. Okay, the method of factoring ax squared plus bx plus c is by splitting the value of b into 2 integers. And the way I get that, it says their product is ac, so multiply to ac. So that would be the first term and your constant, and sum to b, so add to the middle. Which makes sense, because I'm just taking that middle term and I'm splitting it apart. And that's what I'm going to do. So very similar to inspection, I add to the middle term, but here I'm going to find ones that multiply to the product of a times c. Okay, that's the only difference. And we call it decomposition. Well, if you look up the definition of decomposition.
Decompose. Definition of decompose. To separate into constituent parts or elements or into simpler compounds.
It means to break apart, right? It means to, like you have your compost, there is decomposition happening in there, to break apart, to fall apart. So we are decomposing, or we are breaking apart that B term. Okay, I think it makes more sense to do decomp just by doing it. So that's what we're going to do. We're going to go through a couple examples, and I'll show you how to work through decomp. So class example number 3, and we're going to do A. 2x squared plus 7x plus 6. Before I get started, look for a common factor. Can I factor out a GCF? No. But always, 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 always look for a common factor. Okay, well, I noticed that it's a 2x squared, so I can't use inspection. I can only use an inspection when it's just x squared, 1x squared, but this is something different. So I'm going to do decomp. And what I look for is this is going to multiply to a number and add to a number. Those are what I'm going to split up into. Well, it's going to add to 7 because it has to add to this middle term, and it's going to multiply to the product of your a and c value, or your coefficient and your constant. So 2 times 6 is 12. Slightly different than inspection. All right, well, those numbers would be multiply to 12, add to 7, 3, and 4. And it doesn't matter if you had said 4 and 3. It really doesn't matter. Do whatever you want. Well, I'm going to take 2x squared plus 7x plus 6. I'm going to decompose it. I'm going to break it apart. This is the method of decomp, to break apart. I'm saying instead of 7x, what if I wrote plus 3x plus 4x? So it's the same thing. This and this are the same polynomial. They represent the same expression, but instead of 7x, I split it up. And the reason I did that is so that I could factor by grouping. I can group the first two terms, and I can group the second two terms, because now this is a method of factoring that I know. I didn't know what to do. I don't know how to factor this in its current state, but if I make it look like this, I'm able to factor by grouping. In the first group, you can factor out an x. You get left with 2x plus 3. And 4x plus 6, oops, sorry, shouldn't have done that bracket. 4x plus 6, I could factor out a 2 plus 2, and you'd be left with 2x plus 3. And you know it worked when you get the same bracket. 2x plus 3, 2x plus 3. You know your factoring worked when you get that GCF within the bracket, so I can factor out a 2x plus 3, and on the inside I have an x plus 2. Okay, well there you go, you did it. So that question, 2x squared plus 7x plus 6, is actually the same one we did with tiles, the very first one we did today, and we got 2x plus 3x plus 2. Hey, that's what we got at the start of class. So there you go. That is decomposition. Find my magic combo, just a little bit different for finding the thing you multiply to, split it up or decompose it, and then I factor by grouping. Okay, let's do one more. 5x squared plus 7x plus 2. Well, find your magic combo. Multiply to 10. 5 and 2 multiplies to 10. I multiply to that product. Add to the middle term, which is 7. Okay, well, what multiplies to 10 and adds to 7? 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. Perfect. Well, I could say, and this isn't something that pops up. You could do this, plus 5x plus 2x plus 2. That absolutely works. If you wanted to instead write plus 2x plus 5x, you're going to get the same answer. We're actually going to get the same two factors, so don't worry about it. Yeah, it really doesn't matter. I'll do this one just because it's how I have it written. So whatever your magic combo is, don't worry about the order. The order is not going to matter as long as it's the two right numbers. Well, now that I have 4 terms, I could factor by grouping. Okay, first term, you could bring out a 5x, and you get left with x plus 1. Second term, I could factor out a positive 2, so plus 2, and then I'd be left with x plus 1. Hey, it worked, because I got the same binomial in my bracket. I got the same piece. 5x, x plus 1, 2x plus 1. This common factor is going to be brought out. Okay, I'm factoring out the x plus 1. X plus 1 out front. I'd be left with a 5x plus 2. And there you go. You factored it using decomp. Solid method. Works. Okay. The best thing about decomp is it is going to work for a large bunch of things. I look to do common factor first. I'm hoping that it's inspection. I'm hoping that I don't have a coefficient here. I'm hoping it's just 1x squared, so I can just use inspection. But when it's not, I can absolutely rely on decomp to work and get me an answer. Okay, this product, if I multiply this out, I would get what I started with. This and this are the same statement. These are the factors that multiply to what I started with. Okay, moving on. 3x squared plus 17x minus 3. All right, I'll do this one and then I'll let you do the next ones ahead of me. Multiply to 6 times negative 3 would be negative 18. Add to your middle term of 17. Okay, that's crucial. That's crucial. That's crucial. Multiply to negative 18, add to 17. Those would be, I believe, 18 and negative 1. Okay, 18 and negative 1. Multiplies to negative 18. Yep, that's the 17. Here is where I said the order that you decompose it, or the order you split your middle term up to, doesn't matter. Absolutely, it doesn't matter. I'm going to get the right answer either way. If I have one negative and one positive, I always write the negative first. And that's just a personal preference. I think it's easier to look at, but you don't have to. But so for me, I'd say minus 1x plus 18x minus 3. And what that does is it makes my second grouping easier. So if you have the choice, if it's 1 and 1, 1 negative, 1 positive, I always put the negative one first. But that's just my personal preference. Okay, factor by grouping. These two together. First term I could factor out an x. I got 6x minus 1. Next term I could factor out a positive 3. Plus 3. You get 6x minus 1. Hey, it worked because I got the same bracket and the same bracket. Okay, same bracket and same bracket. Equals, factor out your 6x minus 1. And I'd be left with an x plus 3. Okay, there you go. And here is where, maybe I'll just do it quickly because I have space below. We could do a check, a really informal check if we wanted. The whole point of this is saying 6x minus 1 times x plus 3. That is supposed to give me this, the original thing I started with. So let's try. Okay, distribute, I get 6x squared plus 18x. And then I subtract 1x. And then I subtract 3. And that gives me 6x squared plus 17x minus 3. Hey, it worked. So my factor, these two factors, the factored version, it multiplies out to what I started with, so I know it's the correct answer. Okay, which is great, which is what I'm hoping for. Alrighty, I'm going to do B, and then I'll let you do C ahead of me. Okay, 3n squared minus 2n minus 8. All right. Well, multiply 2. 3 times negative 8 would be negative 24. And add 2. And add 2, negative 2. Well, those numbers would be negative 6 and positive 4. And again, okay, I'm splitting up 3n squared. I'm going to decompose that negative 2. And I could write it as minus 6n plus 4n, or the other way, plus 4n minus 6n. I always write the negative first if I have the chance. Okay, just because it makes it easier moving forward. Now that I have that, I can factor by grouping. Group your first two terms, group your second two terms, and I can factor out a GCF from each of them. I get 3n that I could factor out. I get an n minus 2. Plus 4n and negative 8, I could factor out a 2. And I'd be left with n minus 2. Hey, it worked. I got the same thing in the brackets. Equals, factor out that common factor of n minus 2. You get left with a 3n and a plus 2. There you go, factored. All right, C, I will let you do ahead of me. So pause the video and then do it ahead of me.
A few minutes later.
Okay, and we are jumping back in. I've started factoring C. Hopefully you tried this one ahead of me and maybe you get the right answer. I'll quickly finish it. I had to multiply to 12. 12 times 1 is 12. That's the product I'm looking for. Add to the middle term of negative 8. And these are both negative, negative 2 and negative 6. So my kind of goal or my idea of always writing the negative one first doesn't matter because they're both negative. So factor by grouping. The first two terms, I could factor out a 2x. And you get left with 6x minus 1. In the next grouping, negative 6x plus 1, I always have to factor out the negative if it's on the first term of the group. So 6x and 1 don't have any common factors, but I have to factor out the negative. I have to divide by negative 1. So minus 1, 6x, and then I would have factored out 1 divided by negative 1 is negative 1. And that also helps me to get the same bracket. So that's a little bit tricky, always having to factor out that negative, and that's why I choose to just write it first, and then I don't have to worry about that problem. But I can finish it up. 6x minus 1, that's the common factor, and you're left with a 2x and minus 1. There you go, factored. Alrighty, moving on. Let's do a couple more examples. We'll go from there. Okay, factor 15 minus 7y minus 2y squared, and then I have 15k squared plus 5k minus 10. All right. Well, the great thing about decomp is I can factor a variety of things. I don't really have to worry about it. So the first one, it kind of looks awkward, but I can handle it. Okay, let's just treat it exactly how it is and see how it goes. Multiply 2. Well, 15 times negative 2 would be negative 30. And add to the middle one, negative 7. Well, that would be negative 10 and positive 3. And I'm choosing to put the negative first because it's going to make it easier for me. Okay, 15 minus 10y plus 3y minus 2y squared. I'm decomposing. Okay, I'm decomposing, just the middle term, negative 7y. I still have negative 7y. I just wrote it a little differently. And now I can factor by grouping. There you go. First group, I could factor out a 5. And you'd get 3 minus 2y. Next term, you could factor out a y. And you'd get 3 minus 2y. Hey, it worked. 3 minus 2y, 3 minus 2y. I have the same bracket. I can factor that out. And I get left with a 5 and a positive y. So even when things maybe look a little weird, try decomp, because there's a pretty good chance that it works. It's a really, really, really solid method. Okay, B, you are going to do ahead of me, and then we'll move on to the last bit of the lesson. So go ahead and try that ahead of me.
A little longer than a few minutes later.
All right, and I'm jumping in again partially the way through. And what I'm hoping you realized, 15k squared plus 5k minus 10, hey, I have a common factor. So before I look at any method of factoring, I always factor out the GCF, which in this case is 5. And then I can factor what I see on the inside. 3k squared plus k minus 2. I'm going to factor that. Multiply to negative 6. Add to the middle term of 1. Those numbers are negative 2 and 3. So I decompose it. I break it apart. And now I can factor by grouping. And I'm just factoring all this stuff on the inside. Okay, so I would have, you have your 5. And then you've got, well, 3k squared minus 2k. I could have factored out a k. And I get 3k minus 2. And then plus, 3k minus 2 doesn't have a common factor. When I don't have a common factor, the biggest thing I factor out is a positive 1, which doesn't change anything. Oops, that's supposed to be a minus. 3k minus 2. Okay, so when I don't have a common factor, I just factor out a 1. But this worked beautifully, because now I have this common factor, and I am done. I have your 5. You factored out the 3k minus 2, and you got left with a k plus 1. So always, 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 always remembering to factor out the GCF first. And if I do that, I am good to go. Okay, no issues if I do that. Alrighty, we're going to move on to one more example, and that'll finish up the lesson on decomp for today. So it says factoring trinomials of the form ax squared plus bxy plus cy squared. So this is when I'm dealing with maybe 2 variables, right? Maybe I have 2 variables involved. I could totally handle this. Okay, it's not anything too crazy. Decomp works for such a large variety of things. You can try decomp and see if it works. Okay, so multiply. Well, I always multiply to the product of the first and last term. So 2 times 2, multiply to 4. But I'm adding to negative 5, the middle one. Those numbers would be negative 4 and negative 1. Okay, so I decompose 2x squared minus an xy minus 4xy plus your 2y squared. So I'm just taking whatever the middle term was and splitting it up. I'm just decomposing that middle term. That's nothing new. Okay. Well, now I could factor by grouping. First group, second group, careful with that negative. Both of my terms were negative, so I couldn't avoid it. 2x squared minus xy. I could factor out an x. And I get 2x minus y. And then the next one, minus 4xy plus 2y squared. I have to factor out that negative. And both terms contain a y. So negative y. I'd be left with, oh, and I could factor out a 2. So my negative 2y. I get 2x. And then this was 2y squared divided by a negative. So minus y squared divided by y is y. And hey, it worked. I have the same bracket. 2x minus y, 2x minus y. I can factor that out. And I'm good to go. So, hey, decomp works for a wide variety of things. That's awesome. It's not my first method of factoring. It's not the first thing I look to do, but it'll get me my answer. Okay, it works for a variety of things. Okay, last time I'm going to tell you to pause, do be ahead of me, and then that'll be it for today.
A few moments later.
And there you have it. The answer for B, factored by decomp, factored the same exact way. So that's it. Okay, we can move on to the homework, which I'll show you here. With decomp, it's just about practicing. With all the factoring, the more I practice, the better I'm going to get, and the more comfortable it becomes. And yeah, decomp is a huge, huge way. So just a reminder, always look for the GCF first. Hopefully I can just use inspection, but when I can't, when my first coefficient is not 1, then I use decomp, which we know how to do. So there's your homework. 3 odd, 4 odd, 7, and 9 AC. And there you have it, folks. Another video in the books. That is decomposition. So make sure you try the homework. Make sure you ask lots of questions. And I will respond in a video or just some text. And book a one-on-one appointment. We can set up a Google Meet to go through some things together if you're struggling. And that is it for today. So smash that like button, hit subscribe, all of that. And I will see everyone tomorrow.